Welcome to Recon Walls video tutorial series. In this video, I will briefly explain some of the challenges that water can add to your retaining wall design, as well as the process for completing water, buoyancy, and rapid drawdown analysis using Recon Wall 4.0. Water adds several design challenges to retaining walls that must be addressed. These key challenges include buoyancy, bearing capacity, and differential pressure, sometimes referred to as rapid drawdown. When these conditions are present, they should be considered regardless of whether you're doing a gravity wall or MSE wall analysis. Buoyancy is an upward force exerted on an object by a fluid such as water. When objects are fully submerged, the effective weight of the object is reduced by the buoyant forces. In the case of retaining walls, a partially or fully submerged wall results in the reduction of both driving and resisting forces. The presence of water and the submerging of the wall may not control in the analysis, but given its effect, it is recommended that it be checked. Using standard analysis, Recon Wall 4.0 determines an ultimate bearing capacity, assuming that the water table is located well below the foundation of the wall. If the water table is located close to the anticipated foundation elevation, the bearing capacity should be adjusted accordingly, since the soils below the water table have a lower capacity due to their reduced weight. In some retaining wall water applications, it is possible that the water in front of the wall may drain at a more rapid rate than the water behind the wall. This difference in water elevation is referred to as rapid drawdown and creates differential hydrostatic forces on the wall. AASHTO recommends that at a minimum, differential pressure equal to 3 feet be considered in the design of structures that may become submerged. Since consideration for rapid drawdown can have a significant effect on wall requirements, Recon recommends placing a rapidly draining backfill material starting 1 foot behind the heel of the base block and extending up at a 1:1 to finished grade. Placement of a free draining backfill material within this area reduces the potential for rapid drawdown. In either case, Recon Wall 4.0 has the ability to analyze your wall for the effects of rapid drawdown. Prior to introducing the effects of water on your wall section, Recon recommends completing your analysis under dry conditions. Once you have a section that meets stability and bearing requirements, whether it be a gravity or MSE wall, you are ready to introduce water and reanalyze your section. To include the effects of water using Recon Wall 4.0, start by clicking on Geometry from the side menu to go to the Section Geometry screen. Near the center of the screen, there is a checkbox labeled Water within B Depth. Checking this box will bring up several other boxes that will allow you to input your water analysis parameters. If you are analyzing a wall that may be submerged, you will want to leave the water above the footing box selected. At this point, you can input the height of the water at the front and back of the units, as well as the back extent of your MSE section. Once you have entered the water heights, it is important that you click the Update Design button near the top of the screen so that you can visually see the effects of water on your previously analyzed section completed under dry conditions. Once you have clicked Update Design, a water elevation line will show up on the graphic. At this point, you should manually change block sizes or grid lengths as required to satisfy stability requirements with the effects of water on your section. It should be noted that the highest water elevation that the wall could be subjected to may not control in the analysis. For this reason, Recon recommends starting at the highest water elevation and then rechecking at lesser intermediate water elevations to confirm your wall section's stability. To check for rapid drawdown, you will want to input different values for the height of the water in front and back of the wall. Once again, you should use the Update Design button to check for the effects of rapid drawdown and make adjustments as needed. It is recommended that this process for checking the effects of rapid drawdown also be completed on an incremental basis, starting with your highest water elevation at the back of the units. As previously mentioned, dry condition analysis within Recon Wall 4.0 assumes that the water table is located well below the footing for calculating allowable bearing capacities. If your water table elevation is known and is located near the anticipated foundation elevation, you should input this information so that the allowable bearing capacity is adjusted accordingly. To include water table information, Once again, return to the section Geometry screen and check the box titled Water within B depth. This time, uncheck the box titled Water is above the footing. This will reduce your input options down to just one. Now, input the depth beneath the footing to the water table and proceed with your analysis by clicking on the Update Design button. At this point, you may manually change block sizes or grid lengths as needed to satisfy bearing requirements. Well, thanks for watching this water, buoyancy, and rapid drawdown tutorial video for Recon Wall 4.0. If you have any additional questions regarding water applications or your analysis, please refer to the software help menu or contact us directly and we will be glad to help you out.